This is a video on propagation of an action potential in a neuron. Let's identify what an action potential is. An action potential is nerve impulses that are self-generating waves of electrochemical activity that allows neurons to carry a signal over distances. Let's identify the structure of a neuron. This is how the structure of a neuron looks like. It is composed of dendrites, axons, nucleus, a myelin sheath, axon hillock, a soma body, and axon terminals. Let's identify what each structure does. Dendrites will convey incoming messages toward the body. They are short, highly branched signal receptive regions of a nerve cell, which is very important. Nodes of Rabiner hold things together in the cell and myelin sheath. As you can see, there are all these right here. Here we have an axon, and an axon will be the impulse generating and conducting region of a neuron. A neuron will be composed of dendrites and axons. A Schwann cell, which is in the neuron, runs along the neuron covered by myelin. It makes the action potential run smoother with the myelin covered. Myelin sheath of an axon is the whitish fatty protein layer. It serves to protect and insulate the axon. It increases the speed of transmission of nerve impulses, only associates with axons, not dendrites. Let's identify two types of cells in a neuron. So there's neuroglia, also referred to as glia cells, and they are different from nerve cells. The major distinction is that they do not participate in synaptic interactions and electrical signaling. Usually this means that glia means glue in Greek, which represents the support of the cells that are provided in the nervous system. Over here we have an oligodendrocyte, another type of cell, and these are the myelinating cells of the central nervous system, which are important. Now we have CNS and PNS, which are two different types of systems but all composed in one. So there's the peripheral nervous system and there is the central nervous system. The central nervous system will consist of brain and spinal cords. The central nervous system is composed entirely of two kinds of specialized cells, neurons and glia. And in order for the action potential to occur, we need the neurons that are in the central nervous system. Without these two types of cells, the CNS would not be able to do what it does, which is having to do with our minds and how our bodies move. The CNS, or the peripheral nervous system, consists of nerves and ganglia. Because the nervous system has two parts, the CNS and PNS, the PNS transmits action potentials to the CNS. So they are both important for an action potential. Let's move down to the voltage-gated channels that will allow an action potential to occur. Down here we have a description or a graphic of sodium and potassium pumps, also known as voltage-gated channels. Ions of sodium and ions of potassium will flow in and out of the cell membrane, allowing an action potential to occur. Okay, so in the first one, we have the interstitial fluid, which consists of sodium outside of the cell. Usually positive ions and negative charges are on the outside and on the inside. There are 4 steps into allowing the ions to come in and out of the cell for an action potential to occur. There is something really important about an action potential, which consists of membrane resistance. Membrane resistance allows ions to pass at a higher speed if it is decreased. If membrane resistance is decreased, then the ions are able to flow much quicker and faster to allow the action potential to occur. Down here we have a graphic of threshold, depolarization, repolarization, and resting period. For threshold, we allow the action potential to initiate the stage at this point, starting at a charge of 70, and it moves up into depolarization, allowing it to become a more positive charge, allowing voltage-gated channels of sodium to open. Sodium floods into the cell membrane, allowing the channels to stay open for sodium to come in. After that, we have the step of repolarization. Sodium channels close, potassium channels open and go out of the cell. The last stage will be the resting period. No other action potential can occur unless something triggers the membrane. After this, both channels are closed. 3 sodiums go into the cell and 2 stay outside as potassium. There are a few more terms we'd like to go over that pertain to action potential. There is continuous conduction, which is what occurs without any myelin covering the axons. It is another form of propagation, but not very efficient to use. And there is length constant. Length constant is how far voltage can spread from the axon. And the last one is saltatory conjunction. Saltatory will allow the nerve to impulse and conduct or receive help in getting signals from one place to another in a fast, efficient way. To remember this, remember saltare in the Latin terms means leap. Okay, so this is all I have for action potential that occurs in a neuron.